Hello. Today we're going to talk about stoichiometry and how we use stoichiometry to answer a typical question for chemical labs. How much products will be formed from specific amount of reactants, or how much reagents must be used to obtain a specific amount of products. You um, took some labs, and you know that when you read an instruction, usually it says take 2 milliliters of reactant A, right? And add, for example, 1 gram or one piece of metal B in this test tube. So to make this instruction, chemists need to understand how much exactly, um, as I can say, atoms are in this piece of metal, right? And to calculate this specific amount, we can use a mole method, and today I will explain you how to use it and how to understand this mole method, mole ratio for your purposes. So, for example, we have an we have a chemical reaction, uh, and we describe this chemical reaction with this equation. So, nitrogen gas combines with hydrogen gas, right? So let me add something here. Gas, uh, hydrogen gas, right? And ammonia gas formed in this reaction, right? So you can see that this equation is balanced, right? We can check. Nitrogen, we have two nitrogen atoms in the left side, and we have two nitrogen atoms in the right side. So two here and two here, right? We have six hydrogen at the left and six hydrogen at the right side. So this equation is completely balanced. Uh, what coefficients mean according to quantity of atoms, right? So we can read these coefficients like that. Uh, one molecule of nitrogen can react with 3 molecules of hydrogen gas, and 2 molecules of ammonia is formed in this reaction. Or we can go with moles. So it's just like ratio. For example, if I have not just one molecule of nitrogen, and I will have much bigger amount of nitrogen molecules, or let's say I have 1 mole of them, right? So how many hydrogen atoms I will need? 3 moles, correct? And exactly the same ratio, 3 times greater, 3 times bigger than amount of nitrogen, right? And according to this coefficient 2, in front of NH3, we have 2 moles amount of ammonia is being formed here. We can do more, actually. What if we have 2 moles of nitrogen gas? So just compare these 2 moles to this 1 mole, right? So I have, for example, I have to cook some cookies, right? And I know that out of this recipe in the cooking book, I can have 20 cookies ready after I done. But I need not 20, I need 40. I need 2 times greater amount of, right? So what I need to do? I need to double the amount of reactants, correct? So, and I'm going this way in this equation. What if I have 2 times more, 2 times bigger amount of nitrogen here? That gives me bigger amount of hydrogen here. So 2 times more bigger. 2 times by 3 moles, right? And I will have ammonia 2 times by 2 moles, right? So, and you can see that this equation actually gives us a possibility to calculate amounts mole ratio between reagents and products, and it can and it lets us to calculate the amount if we have different amount, not like our coefficients, right? So, and today after this lecture, you will be capable of calculating all these ratios. Let's do some concepts checking. So the first one, we have a reaction where where copper sulfide is being roasted, right, with oxygen. So this is combustion reaction. Um, it's a kind of burning, right? So we have copper to sulfide reacts with oxygen. You can see this equation is completely balanced, and our molar ratio is copper S plus 3O2 solid gas gives us 2 copper O solid and 2SO2 gas. What is the molar ratio for this equation? For example, we have coefficients here 2, 3, 2, and 2. And these coefficients shows us ratio between components of this reaction, between reactants and products. These two can mean that 2 units of copper S can react with 3 molecules of oxygen, right? Please pay attention. For oxygen, I use molecules because this is covalent compound. But for copper sulfide, I cannot use molecules because it's ionic compound. So I use units, right? And these two means that 2 units of copper oxide being formed here and 2 molecules of SO2 is forming here, right? But we can have bigger amount of units, not just one or two. We can have billions of units, right? Or we can have much bigger number of units than just billion. We can have mole, right? One mole. I just remind you that one mole has 6.02 multiplied by 10 in the power 23 units. Things, right? So what if I have this amount of copper as units, right? So let's say 2 moles of copper as. That means that I have 2 times by 6.02 multiplied by 10 in the power 23 units, right? And how many oxygen will I need for that? It's obviously 3, right? Because look at the coefficients. So the ratio is 2 to 3, and here the ratio is 2 to 3, the same ratio. And doesn't matter that here in the first ratio we have just units and molecules, and on the second ratio we have moles. The ratio in general still the same, right? So and here it will be 2 moles and 2 moles also. Okay. What if I have not 2 moles? I have 10.0 mole of copper. How many copper 2? How many moles of oxygen are required for this reaction? We have a ratio. Amount of moles for oxygen will be moles for oxygen will be 10.0 moles multiplied by 3 moles divided by 2. So I'm just comparing 10 with 2. 10 is 5 times greater than 2 moles, right? That's why I will need 5 times greater amount of oxygen too. And this amount will be 15.0 moles. Proper number of significant figures, I will need to look at what was given. Here was 3 significant figures, and these ratio we just made up out of this equation, so it doesn't count. That's why I need to have 3 significant figures here. So 15 moles of oxygen is required to roast 10 moles of copper to sulfate. Okay. Okay, the next one, B. How many grams of sulfur dioxide are formed when 7.5 moles of copper to sulfide is roasted? So I need to write my equation again. So it will be 2 copper S plus 3 O2 solid and gas, and I will have 2 copper O, copper 2 oxide plus 2 SO2 gas. My molar ratio molar ratio is 2 moles of copper sulfide, and we need to find how many grams of sulfur dioxide. So I am going to underline sulfur dioxide, and molar ratio between copper to sulfide and um, sulfur dioxide is 2 to 2. Yeah, so 2 moles by 2 moles. So, but no, yeah, but and 7.5 moles of copper to sulfide is given. So, given 7.5 mole of copper to sulfide. And we need to find how many moles of sulfur dioxide is formed here. How we calculate the amount of moles of sulfur dioxide? So amount of moles SO2, how we calculate it? So we have our ratio 2 to 2, but now it's 7.5. Our ratio, our calculation will be like that. See, this line connects with 7.5 and 2 moles, and they go on the top here, 7.5 mole multiplied by 2 moles, right? Divided by 2 moles. And we will have 2 and 2 are cancelled. So we have 7.5 moles, the same amount of sulfur dioxide. Why is it the same amount? Because the molar ratio is 2 to 2. It shows that amount of copper sulfide and amount of sulfur dioxide are equal to each other. That's why we have equal amount of sulfur dioxide as the amount of copper sulfide here in this equation. Okay, so we found amount of moles of sulfur oxide, but we need to find how many grams of sulfur dioxide. To go from amount of moles to grams, we need to use molar mass. So grams, this is mass, right? So to find mass of sulfur dioxide, we need amount of moles of sulfur dioxide multiplied by molar mass of sulfur dioxide. And in periodic table we can find atomic masses, mass for sulfur and for oxygen, and can calculate a molar mass for sulfur dioxide. So amount of moles sulfur dioxide, it will be 7.5 moles, and molar mass of SO2 is 64 grams per mole. So mole and mole are cancelled, and we need to use our calculator to calculate what do we have here. So and I'm multiplying 7.5 by 64, and now I have 480 grams of sulfur dioxide. This is one way to do this calculation. So let me clean it, and I will show you another way, okay? We need to erase it. Erase. Yeah, it is erasing now. I need to show you a different way to calculate, and you will choose which one is more understandable for you. So let's do this. Yeah, okay. So we have an equation, the same equation, and we have molar ratio still the same between copper sulfide and sulfur dioxide. And I suggest you underline compounds which you need to for calculation. So I am underlining copper sulfide and sulfur dioxide. So, and you'll always start with molar ratio. Molar ratio. Molar ratio shows us the amount of moles which you need to have this reaction. So if you have 2 moles of copper sulfide, you will end up with 2 moles of sulfur dioxide, right? But it's given that 7.5 moles of copper to sulfide is being roasted here. So given 7.5. And now this is different way to calculate it. So you will start with which is given, so 7.5 moles. And you multiply by your conversion factor. So conversion factor is 2/2. 2 moles by 2 moles, right? And you need end up with grams, because how many grams of sulfur dioxide, right? So we need to go with grams. So, and you know that molar mass shows us how many grams is 1 mole. So 1 mole of sulfur dioxide according to periodic table is 64 grams per mole, and this is my conversion factor, so 64 gram per 1 mole. And I will have 480 grams of sulfur dioxide. So this is mass. So choose the way you like more, and they both correct. So let's do another one. How many grams of oxygen are required to form this mass of copper 2 oxide, right? So we have our equation the same. 2 copper copper S plus 3O2 copper O2 plus SO2 2 times, right? So you start with molar ratio, and what compound do we need? So copper 2 oxide, I underline it, right? And oxygen. I need oxygen and copper 2 oxide. So for oxygen, molar ratio is 3 moles because coefficient in front of oxygen is 3 and 2 moles here. So molar ratio is 3 moles to 2 moles, right? But we have 2.86 gram of copper to oxide. We do not have any amount of moles, but we need it to understand how many moles of oxygen do we need. We need to understand, we need to calculate how many moles of copper 2 oxide is in this mass, right? So we start with this mass, so 2.86 gram of copper 2 oxide. Yeah, but I need to calculate how many moles it is. So I will use conversion factor, and conversion factor will be 1 mole of copper 2 oxide has molar mass 80 gram per mole. 80 gram per mole, right? So this is my conversion factor. Molar mass shows us how many grams per 1 mole in any kind of compound. So this is our amount of moles for copper 2 oxide, right? But after I need to end up with amount of moles for oxygen. So, and I have my conversion factor 3 to 2, right? And if I have amount of moles for copper, I will need my conversion factor like this, that amount of moles for copper oxide will be here. And amount of moles for oxygen will be here, right? And now I need how many grams of oxygen are required here. So I will use molar mass for oxygen. So, if I need to end up with grams, right? So I need to have grams at the top of our equation, right? So it will be 32 grams per 1 mole. And now let's just check what is cancelled out here. Grams, right? Moles and moles. And we end up with grams. That is correct. Okay, we need grams. And now I'm going to take my calculator and just multiply all these. So I'm multiplying 2.86 multiply by 1, right? Divide by 80. Then I need to multiply by 3 and divide by 2. Then I need to multiply by 32. And I have 1.716 grams, and we need 3 significant figures because it's 2.86 gram given of copper 2 oxide, so I need to round this result, so it will be 1.72 grams. Okay, let's do another example. For example, I have my reaction NaOH can react with copper sulfate and copper OH 2 times plus Na2SO4 is being formed. So please, first of all, we need to balance this equation, right? So we start with sodium. Sodium, one sodium here and two sodium here. So we need two, coefficient 2 in front of sodium hydroxide formula. So we good with sodium, right? So now another metal, copper here and copper here, they are equal, they're balanced. Sulfur and sulfur, 1 and 1 are balanced too, and total amount of hydrogen and at the left side, two hydrogen atoms and two hydrogen atoms at the right side, so it balanced, and oxygen is balanced too. So now we have completely balanced equation, and as a reminder, this is double displacement reaction. And let's check in a solubility table, because we need to uh, mention their state. Are they solid or liquid or in a solution, right? So according to solubility table, sodium hydroxide is soluble, so I will use AQ. That means that this is a solution. For copper sulfate, it will be a solution too, right? For copper OH, two times it's insoluble, so I will use this sign, or I will use this as, right, solid, and this is soluble too. For example, what if I need to calculate the mass of precipitate here, right? If we have certain amount of sodium hydroxide. So let's say I have 8 grams of sodium hydroxide, and I need to calculate how many grams of copper hydroxide I will end up with. Okay? We start with equation, and we start with molar ratio. So the first of all, coefficient 2 in front of NaOH gives us 2 moles, or 2 any kind of units, any kind of portion, 2 billions, or 2 moles, or just 2 units, 2, right? And C, in front of copper hydroxide, there is no coefficient. That means that we have just 1 mole, 2 times smaller amount of copper hydroxide. Okay? This is molar ratio. Molar ratio 2 to 1, right? So every time amount of copper hydroxide will be 2 times smaller than amount of sodium hydroxide. But again, we do not have any amount of moles. Mass of sodium hydroxide is given, but we need amount of moles. We need to calculate, first of all, okay, we need to calculate the amount of moles for sodium hydroxide, right? This is the second way I'm showing you how to solve this kind of problems. Amount of moles. So amount of moles, to calculate it, we need to use molar mass. So to calculate amount of moles, we need to have mass of sodium hydroxide and divide by its molar mass. This is a kind of formula. Please use it, and please just have it in front of you to look at it when you be doing this. Okay, so mass we have mass 8 grams and molar mass for sodium hydroxide. Sodium is 23, 16, and 1 for hydrogen, right? So together it's 40 gram per mole. Okay? So we need to divide 8 by 40. It will be 1/5, or I can use another kind of 0.02. Grams are cancelled. We have moles, right? So we have 0.2 moles of sodium hydroxide. And I am going to write it down here. 0.2 moles. Given. I calculated that our 8 grams of sodium hydroxide equals to 0.2 moles of sodium hydroxide. And now we can calculate the second step. We can calculate amount of moles for copper hydroxide, right? We have molar ratio 2 to 1. 2 moles. Oh, no, I'm sorry. We need to start with what is given. 0.2 moles, right? And here we need to have 1, because we start with this 1 to 1 mole to 2 mole. So moles are cancelled out, so we have 0.1 mole of copper hydroxide. And the third step, we need to calculate mass of copper hydroxide. To do that, we need to use this formula, right? So they are connected, mass and amount of moles connected through molar mass. So to find mass, we need amount of moles for this compound, for copper OH 2 times, multiply by molar mass for copper OH 2 times. And we have amount of moles 0.1 mole multiply by, and molar mass will be 64 for copper and 16 plus 1 2 times. So when we calculate, we will have 64 plus 34, it will be 98, multiplied by 98 gram per mole. So moles are cancelled, and we have 9.8 grams. And this is mass of copper hydroxide, which we have. Okay, let's do something else. So let's say we have these equations. So phosphorus can react with chlorine, solid, gas, and phosphorus pentachloride is being formed. It's solid. Okay, so the first of all, we need to balance this equation, correct? So phosphorus 1 and 1, but chlorine 2 and 5 here. And you know what to do? We need to use coefficient 2 in front of PCl5 to make the number of chlorine atoms even. Right, so now we have even amount of chlorine, it's 10, and now we need a coefficient 5 in front of Cl2. So chlorine is balanced and phosphorus 2. Right, so this equation is balanced. Let's write two conversion factors between amount of phosphorus and chlorine. So the first can be like this. Moles of phosphorus, 2 moles of chlorine, right? And the second can be moles of chlorine, 2 moles of phosphorus. For the first one, we use moles of phosphorus. Coefficient 2 gives us 2 here, and 5 gives us 5 here, right? The first one. And the second one will be 5 and 2. So, and it's up to you. It's up to what you need right now. You can use the first one or the second conversion factor. And let's say let's say that we have a problem that we need to find how many moles of chlorine we need to produce 3.2 moles of PCl5, right? So first of all, we need our molar ratio. Molar ratio is 5 to 2. Always start with what you given. So it's 3.2 moles of 3.2 moles of PCl5, right? PCl5. Okay. And this and we will need to find how many moles of chlorine, right? So we need to use a conversion factor between chlorine and PCl5. So we can use two of them too. So or 2 moles of PCl5 to 5 moles of Cl2, right? Or we can use another one, 5 moles of Cl2 to 2 moles of PCl5. So if we start with PCl5 here, so we need to use this conversion factor where PCl5 can be cancelled later. So I will use this, the second one, conversion factor. So 2 moles of PCl5 here and 5 moles of Cl5 are at the top, right? So, and moles are cancelled out here, and PCl5 too, right? And we end up with amount of moles for chlorine, or it's 2, not 5. So and now we just need to multiply 3.2 by 5 and divide by 2, right? So let's do it together. So it will be 3.2 multiplied by 5 and divided by 2. 8. 8 moles of chlorine. And now, is it correct answer, or this is not a proper amount of significant figures? What do you think about that? I think that you answered correctly because that is not what we need. We need two significant figures here. So that's why I will use 8.0 moles of chlorine. Okay, and what if we were asked to find mass of chlorine gas? What do we need to do? The first of all, we did correct thing. We found an amount of chlorine gas, right? So we found the amount of moles. Now we need to calculate mass. How many grams is 8 moles of chlorine, right? So mass of chlorine will be amount of moles for chlorine multiply by its molar mass. And molar mass of chlorine is 71 gram per mole. So when I multiply, I will get the result 5, 6, 8 grams because moles are cancelled. So, and I need two significant figures so I can round it to 570 grams of chlorine. So, this is examples that we did together that will help you to do by yourself, to finish by yourself these practice problems set 1. And as you can see, we already discussed molar ratios. We already discussed how to find moles if moles are given, how to find mass or moles if mass are given. So now we know that relationships between moles and mass, and you will be able to finish this practice problem by yourself. Just to remind you that amount of moles, you need to calculate it by dividing mass by molar mass. And mass you can calculate by multiplying amount of moles by molar mass. Please memorize these two formulas. They will help you to finish your homework.